What's good, guys? Welcome back to another video. Today we're going to be going over log word problems. Essentially, a student had a few questions on a quiz that they had. This is like a practice test type of thing. And I kind of wanted to go through kind of my thought process as how I would walk through these word problem questions, good things to look out for, some kind of key wording that I'm trying to really focus on in order to better understand the problem, and all in all, how to do these. So without further ado, let's get right to it. All right, so I'm going to have the questions pulled up on the screen here, but I'm also going to read these out loud. The value of a particular investment follows a pattern of exponential growth. In the year 2000, you invested money in a money market account. The value of your investment, T years after 2000, is given by the exponential growth model, A equals 1000 e to the 0.069 t. By what percentage is the account increasing each year? All right, so the first thing that we have to understand is, how does the log or exponential equation work? So in this case, we're given A is equal to 1000 e to the 0.069 t. All right, well, in this case, A is equal to account, right? This is our account balance after whatever we plug in for t years. Okay, 1000 is the initial investment. E to the 0.069 t is actually our growth rate. Now, 0.069 in this case is actually going to be the answer here. Why? Well, what it's asking us is, if we go back to the question, by what percentage is the account increasing each year? This value right here is actually our growth factor. T in years is just simply how much time is passing. So what I would do is I'd take 0.069. Well, let's turn that thing into a percentage. I got 6.9%. Let's look at the answers here. I got 7.3, 7.6, 7.5, and look at that, 6.9%, leading us to our final answer of 6.9%. Again, on this particular question, all I'm looking for is breaking down this equation. What does each part mean? We know that this thing is set equal to the account value at any particular time that we plug in. That's A. Thousands our initial value. E is just something that helps us with our growth. Again, E is just a natural number in the real world. 0.069 is actually our growth factor. And then T is our time in years, leaving us with our answer having to be 0.069, aka 6.9%. All right, let's head on over to that next one. All right, the next one reads like this. The function f of x equals 1 plus 1.4 natural log of x plus 1 models the average number of free throws a basketball player can make consecutively during practice as a function of time, where x is the number of consecutive days the basketball player has practiced for 2 hours. After how many days of practice can the basketball player make an average of 9 consecutive free throws? All right, so our equation is given. F of x equals 1 plus 1.4 natural log of x plus 1. Now, in order to answer this equation, we have to ask ourselves again, what does it give us, and what are we looking for? Well, in this case, x is the number of consecutive days the basketball player has practiced for 2 hours. Okay, so that's just the number of days. X is equal to number of days. What we're trying to find is, how many days of practice can the basketball player make an average of 9 consecutive free throws? So the thing that we're given in this case is 9 consecutive free throws. Well, where can I plug that in? Well, I can't plug that in for x because x is number of days. So that means that is f of x. This is 9 consecutive free throws. That's what we're solving for. And that makes sense because the function models the average number of free throws a basketball player can make consecutively. So that's what this models. That is what f of x is. That is what I'm plugging right here. So 9 equals 1 plus 1.4 natural log x plus 1. From here, it's just algebra. I'm going to subtract 1 from both sides. 8 equals 1.4 natural log x plus 1. Divide everything by 1.4. And then I get I'll just leave it as 8 divided by 1.4 equals natural log of x plus 1. Anytime you want to get rid of the natural log, it's actually best just to exponentiate everything. So in other words, what I'm going to do is I'm going to rewrite this thing over e, because this thing is base e. So e, then the answer is the exponent. The argument becomes the answer. So in this case, I get e of natural log, or e raised to the 8 over 1.4 power is equal to x plus 1. So then at the end of this, walk over here, I get x is equal to e 8 over 1.4 minus 1. Now I can plug that into a calculator and solve that, but that's going to be our answer for this next one. Again, main thing here is identifying where to place this 9, realizing that the model represents the consecutive amount of free throws, x represents days, we're provided free throws, plug those free throws in, and then just solve. All right, next one. All right, the pH of a solution ranges from 0 to 14. An acid has a pH less than 7, pure water is neutral, and has a pH of 7. The pH of a solution is given by pH equals negative log x, where x represents the concentration of hydrogen ions in the solution in moles per liter. Find the hydrogen ion concentration if the pH equals 9.4. All right, so we're given that pH is equal to negative log x. Now this question is very similar to the last one in the sense that I'm given a value and I have to determine where it's going to be plugged into. Well, this one, it says pH equals 9.4. So where do you think we plug that in? Exactly. For pH, right? So I get 9.4 is equal to the negative log of x. And then from here, I'm just going to solve. I know that this is negative. That means there's a negative 1 in front. So if I divide everything by negative 1, that gets rid of this negative here. So I get negative 9.4 equals log of x, just like that. Now again, here I'm going to exponentiate this. Log is always inherently base 10. So if you're not provided the base, you can always assume that it's base 10. So here we go. 10 to the negative 9.4 is equal to x, giving us this as our final answer. Again, all I'm looking for is where to plug in these values, right? pH is provided to us, we plug in pH, and then I only have one variable remaining. You can always solve an equation if you're provided with one variable. Exponentiate this term here. Base of the log is the base of the exponent. Answer of a log is always the exponent, and then the argument ends up being the answer here. Rearrange it, and there you go. All right, let's keep it moving. All right, a dish of lasagna baked at 400 degrees Fahrenheit is taken out of the oven into a kitchen that is 69 degrees Fahrenheit. After 5 minutes, the temperature of the lasagna is 356.8. What will its temperature be 15 minutes after it's taken out of the oven? Round your answer to the nearest degree. And they give us Newton's law of cooling, which is equal to T, remaining temperature, is equal to C plus T sub 0. T sub 0 is always just means T initial value minus C times E raised to the K T power. All right, so what we have to do now is we have to kind of decipher what this all means again. Okay, so T in this case is equal to our temperature. C is our room temperature. T initial is our temperature originally. And then E to the KT power, T being our time, K being our growth rate. That's basically everything that we need to know about this equation. So what I'm going to do from here is I'm going to plug in all the values that have been provided. Well, provided that the dish of lasagna is baked at 400 degrees, okay, and it's taken out of the oven into the kitchen that is 69 degrees Fahrenheit. After 5 minutes, the temperature of the lasagna is 356.8. Okay, so now what am I thinking here? Well, the initial value here is going to be 400, right? It's baked at 400. So when you take it out of the oven, instantly it's 400 degrees. So that's what's going to get replaced here. My T value, my temperature value is that 356.8 value. Okay, the room temperature, well, it says the room is 69 degrees. And then after 5 minutes, I'm going to plug in 5 for T here. And why am I going to plug in 5 for T when it's asking us for 15 minutes after? Well, I need to find my K value. In order to find any type of variable, I need to plug in all of the other variables around it to solve for it. So 356.8 is equal to 69 plus 400 minus 69 times e raised to the k 5 power. All right, so from here now all I'm going to do is I'm just going to solve. Okay, so what I'm going to do first, subtract 69 from both sides. Just like that. Okay, this equals 287.8. Again, is equal to, well, 400 minus 69 here is equal to 331 times ek to the 5th. Okay, I'm going to divide everything by 331. That's going to give me this right here. So now I have 287.8 is equal to e to the 5k. All right, now how do I get rid of the e? Well, what I'm going to do is I'm going to take the natural log of both sides. The natural log of anything with an argument of e just ends up being the exponent here. That's just a log rule. So then this all equals 5k. So I got 5k here. And then last thing I have to do is divide everything by 5. So this 5 comes down here as well. And that ultimately gives me k here. Which is equal to negative 0.027. Now it's irrational, but I am rounding here because there's no point for me to round it anymore. In fact, actually rounds to 0.8 here. Now I have my k value. Well, now let's go to work. All right. So now what do? Well, now that I have my k value, I can basically redo this whole entire equation, but now for the 15 minutes instead of the 5 minutes. So what's different in this case? Well, what's different is before I was given the temperature of 400 degrees, right? I can plug that in for T. This time it's not that case though. I'm actually solving for that. So that's the only thing I'm not going to plug in here. T is equal to 69 plus 400 minus 69. I'm not plugging in my T value, which was actually 356.8. I'm tripping. It's not 400 because 400 is our initial value. It's that 356.8 at 5 minutes value that I'm not plugging in. So e to the 0.027 negative times 15 in this case. And now from here, I'm just solving again. And that's ultimately going to give me 69 plus 331 e to the negative 0.027 times 15. No idea what this is, but I can tell you that it's going to be around 287 degrees Fahrenheit. So, a little bit of a recap on this question here. What we have to do is we have to decipher what it gives us, right? I'm trying to solve for t, but the problem is that I was never given the growth, and in order to solve for a variable, you need all other variables provided. So, how do I solve? Well, I can find the variable. So then that brings me to the next step. Why is all these other numbers provided? Well, 356.8 in that 5 minutes was provided because it allows me to set up an equation where the only missing variable is my growth rate. So then I can solve for the growth rate, which is going to be the same thing regardless because it's growing at the same value, right? It's consistently growing at that growth rate since it's on the same function. So then I can use that growth rate, plug it back into the equation. However, this time, rewrite it so the time isn't 5 but 15 and find that temperature value that we were looking for. All right, next one. All right, so it's looking like we get round 2, a little bit of redemption here. A cup of coffee with temperature 102 degrees Fahrenheit is placed in a freezer with temperature 0 degrees Fahrenheit. After 8 minutes, the temperature of the coffee is 52.5. Well, will its temperature be 13 minutes after it's placed in the freezer? Round your answer to the nearest degree. Okay, so same type of idea for this question because, well, it's still Newton's law of cooling. So rewrite this. C plus T sub 0 minus C in this case, e to the kt. Okay, well, now we have to just identify all the variables that were provided. It said that the freezer was 0 degrees, but that's actually my room temperature. Why? You're thinking like, hey, a freezer's not a room. I mean, it can be depending on if you're like an industrial restaurant, but in this case, it's not. Well, it's not the room temperature in terms of a room, but the space that this thing is occupying. In this case, this cup of coffee is being held in the freezer. So in that case, the room surrounding it is the freezer's temperature, which ends up being 0. So now I got to think about, well, what else am I provided here? Well, I'm provided that the initial temperature was 102 degrees Fahrenheit, and then after 8 minutes, it was only 52.5. So same or different question, same idea. I'm gonna plug everything in here. So 52. Let me double check my numbers here. 0.5, yep, is equal to, well, C is equal to 0, so I don't need to plug it in. 102 e to the k, and then in this case, I think it's 5 again, right? I might be tripping, it might be 8. Yep, 8. Just kidding. All right. So now, here we go again. A little bit different, but kind of the same idea. I got to solve for k here. So divide everything by 102. That gets rid of this part here. Okay, got to take the natural log of both sides. That gets rid of the e. Then I got to divide this thing by 8, making that our growth rate. Okay, so now that we know that k, our growth rate, is equal to negative 0.083, now what we're going to do is the same thing that we had to do last time, where I plug in all of my values, but this time I am solving for t. So again, t in this case is equal to, well, this was not provided, so 102 e. In this case, I know that my growth rate is negative 0.83, and then my t value here is going to be my 15 minutes, actually 13 this time. Plug it in. Again, this is all calculator work at this point, so this is all just going to be equal to around 35 degrees Fahrenheit. So again, same type of question, same type of vibes here. I'm plugging it in, solving for my missing variable, plugging it back in, solving for my actual answer. 2 steps to this case, 2 different uses of the equation, same equation. That's how you get it done. We're on to the last question for today. All right, last one here. The formula A equals 168e raised to the 0.038t models the population of a particular city in thousands t years after 1998. What will happen, when will the population of the city reach 275,000? Okay, so we're given A equals 168 e to the 0.038t. Now, we are given, when will the population of the city reach 275,000? So we have to think, where am I plugging this in? I'm not plugging it in for t, because t is time, so I'm plugging it in for a. Well, wait 1 second. There's very important wording on this question. It says that this models the population of a particular city in thousands, right? So in other words, if we look at this, if I write 275,000 here, right, with all 3 zeros as well, it's already in thousands. So that's actually not going to be thousands. That's going to be millions. So what I have to do is I have to adjust accordingly and only write 275. It's equal to 168e to the 0.038t. And then from here, all it is just some algebra. Divide by 168 on both sides. That gives rid of 168. Take the natural log of both sides. That gives rid of the e. Divide everything by 0.038. That provides me with just t. And ultimately, again, all of this is some calculator stuff. I just plug that into a calculator and get 12.97, or roughly 13 years. And that's basically it, guys. If you guys have any questions like this that you want me to walk through, some quiz questions, study guide, something like that, where I kind of walk through my ideology of how I'm going through these word problems, always feel free to drop them down in the comments below. If you want some one-on-one tutoring, something to get your little test prep going, outside of just videos, always head on over to Mindly Tutor, book your boy, get a lesson in. But until then, I'll see y'all next time. Take care, and as always, peace out.